Hello guys, I'm Varun and today I'll be speaking on the topic deep learning. I'll be covering two aspects of deep learning. The first one will be the most interesting application of deep learning that I've seen till date. The second one will be the application where I think deep learning cannot be useful. So I'll start with a quote from Nick Bostrom that machine intelligence is the last invention that humanity will ever need to make. It's dark in itself, but at the same time, it's quite fascinating. So moving on, we'll start with the topic what is deep learning. So deep learning is an artificial intelligence function that tries to imitate the workings of the human brain in processing data, in creating patterns used for decision making, predictions, etc. So in short, we are saying that deep learning is trying to mimic the behavior of human beings to be precise. Deep learning can be further classified as a subset of machine learning and artificial intelligence that has networks capable of learning unsupervised from data that is unstructured or unlabeled. So that's pretty much like how we humans learn. Like we don't get any labeled data in our day-to-day life. Unlike the data we pass into models that which is usually labeled, we get unlabeled data and we learn from it ourselves. So deep learning tries to imitate that. As you can see in the diagram given below, that deep learning is the subset of artificial intelligence and machine learning. So it's a pretty focused field, unlike AI/ML, which are pretty vast in themselves. So moving on to the uses of deep learning, there are many uses. I have listed four of them. Though the first one is convolutional neural networks. These are the most common forms of deep learning. Then there's recurrent neural networks. There's reinforcement learning for neural networks and autoencoders. I'll be covering autoencoders in this particular video since I'll be covering the topic of deep learning super sampling, which is related to autoencoders, and this technique is being used in the gaming industry for quite a while now. It's been approximately a year since it's been released and it's been doing wonders ever since. So what are autoencoders? So an autoencoder is an artificial neural network that is capable of learning various coding patterns. The simple form, the autoencoder is just like the multi-layer perceptron containing an input layer or one or more hidden layers or an output layer. The main difference between the typical multi-layer perceptron and feed-forward neural network and autoencoder is in the number of nodes at the output layer. In this case, the number of nodes at the output layer is same as the number of nodes in the input layer. And instead of predicting target values as per the output vector, the autoencoder has to predict its inputs. So this is the basic architecture of an autoencoder. Like you can see that we pass the input image, which is of a completely different form. Then it's encoded. This is the latent space. Like this is the smallest possible representation of the image. And from this particular space, the image is rebuilt to our target feature. Like you can see that this image is quite different from what we passed. So that's the basic use of an autoencoder. Moving on. So I have shown the basic use of deep learning super sampling or DLSS, which is a tech by NVIDIA. So the first use is the real-time use of this technology in games. So I have shown the example of Death Stranding, which is a game. As you can see, it might not be apparent in the small image, the actual difference, but it's phenomenal. Believe me, I played the game and it's phenomenal. And then there's the basic architecture of the model that they follow. So what are we basically doing is that we are passing the low input images, low resolution images and motion vectors, and we are passing that through our neural network or autoencoder, and then we are comparing it with the 4K input that we have passed as the ground truth, 16K I mean. So let me just tell you, like DLSS 2.0 has two primary inputs. First is the low resolution A-list image rendered by the game engine, and second is the low resolution motion vector from the same engine. You would ask, why do we even require motion vectors? Like, since there's always some kind of movement in the background in games and all, hence motion vectors help us determine the next frame. Like, it will help us predict the future, and since we are predicting the future from the previous frame, this is referred to as temporal feedback. Like you can see in the definition here, as it uses history to inform the future. So that's temporal feedback, hence the name. Then the AI behind the process of the convolutional autoencoder is that it takes the low resolution image as the input and the high resolution previous frame as the output. Then the network determines on a pixel by pixel basis how to fill or generate the pixels missing pixels in the low resolution image. During the training, the output image is compared to a high quality 16K reference image. So as you can see that we have passed the 1080p image, then there's a 4K image, that's the output, and we are comparing it with the 16K image. Then we compare the difference between these two and we pass that particular thing into the network itself so that it optimizes itself, and that's called temporal feedback. So now I'll talk about some limitations of deep learning. As you all know that there's a limit performance, and what does this mean is that deep learning models usually require high-end hardware for training as they are very resource dependent, and normal people like us cannot continuously train heavy models or something like that. I mean, there are certain platforms like Google Colab, but they are also hardware limited. Then there's the black box AI, poor explainability. Now, if we will consider the GPT-3 model, it recalls 175 billion parameters. Now, that's quite a huge number, and it's pretty much impossible for any human to do so. And we cannot particularly explain, like there's no transparency of how it is doing so. So that's the black box concept, that there's not much transparency between AI and humans. Then there's diminishing returns. What does these mean? That even if we train a model for thousands of epochs on a very nice dataset, it's not guaranteed that the results will be good. They might be bad, they might be extraordinary, but it depends. So like we are not guaranteed a good result every single time. So apart from this field, now the second topic begins, like a field where we can't possibly use deep learning. So I'll just play a video and you just watch it. So as you just saw, that GAN, that is Generative Adversarial Networks, was able to make Pac-Man the whole game with all the basic logic behind it itself, just by looking at the frames. It was trained on 50,000 Pac-Man episodes, and it produced a fully functional playable game for from itself. So that's quite fascinating, but I don't think that it will be able to do so for the complex games. Like this is a pretty basic game which just follows a very basic architecture, like we have to escape from the ghost and all. But now if we consider the complex themes, like some of the names I mentioned are Horizon Zero Dawn, Detroit Become Human, Death Stranding, and Cyberpunk. Horizon Zero Dawn is usually known for its beautiful environment. Like the environment is just so beautiful. Like I don't think that AI will be able to recreate the same level of environment that humans have put so much effort into in a small or even in a greater amount of time. Like that's not possible yet, and I'm focusing on yet, as we don't know what the future has for us. So it might not be able to produce the environment yet. Similarly with Death Stranding, there's a lot of complex physics in this game. Like there are slippery rocks, there's rain, there's snow and everything, and it depends on the type of atmosphere and different types of conditions, how the physics are interacting in this game. Similarly in Detroit Become Human, this game is known for its humongous amount of choices, and there are a lot of choices where you can choose something and something else will happen in the future of the game. So I don't think that AI is capable of reproducing that too at the moment. Then there's Cyberpunk. This is an upcoming game and it's been in development for 7 to 8 years now, and the buzz around this game is quite high, and I don't think that AI will be able to recreate this game no matter how much it tried. So that's my personal opinion. You might think different, but that's my personal opinion, and that brings us to the end of the video. So thank you very much for watching. Hope you enjoyed. Have a nice day and stay safe.